Question number 12 of the worksheet on connected particles. Particle P and Q of mass 0.6 and 0.4 respectively are attached to ends of light inextensible string. So now the weight mg is not going to be vertically downwards. Actually, it will be vertically downwards, mg and mg, but we will be using its components. So we will be using the component in this direction, which is mg cos theta. So for P, it's going to be 6 cos theta. And in this direction, it's going to be 6 sine theta down the slope. Six sine theta parallel to the slope, and similarly this is going to be 4 sine theta and 4 cos theta. Then we also have normal contact force. I'm unable to make straight lines for some reason. Yeah, this would be R and this would be R perpendicular to the contact, and we'll have tension pointing away from the object on both P and Q. Okay, a string passes over a small smooth pulley which is fixed at the top vertical cross section of a triangular prism. The base of the prism is fixed on horizontal ground and each of the sloping sides is smooth. Each sloping side makes an angle theta where sine theta is 0.8. Okay, so if you're given sine theta, that means you can also find cos theta. So sine theta is 0.8, which means if I draw a right angle triangle, this would be theta, this would be 90. 0.8 can be written as 8 over 10. Sine theta is equals to 0.8 or 8 over 10 or even 4 by 5. So opposite over hypotenuse. So that would make this length 3, because we'll apply Pythagoras theorem here. 5 square minus 4 square root is equals to 3. Okay, so that means we now have cos theta as well. Cos theta is going to be 3 over 5, or it's 0.6. Okay, so now we're going to replace cos theta with 0.6 and sine theta by 0.8 moving forward. Okay. Initially, the particles are held at rest on the sloping sides with the string taut. The particles are released and move along the line of the greatest slope. Find the tension in the string and the acceleration of the particles. Okay, so how will the movement take place? Will P go down or will Q go down when this system moves? जी आयशा, P नीचे जाएगा या Q नीचे जाएगा? How will this move? क्योंकि उस पर डिपेंड करेगा ना, फॉरवर्ड फोर्स क्या लेंगे और बैकवर्ड फोर्स क्या लेंगे। जी
क्यों नीचे जाएगा?
नहीं, जिसका वेट ज्यादा है ना वो नीचे जाए। ठीक है, so it's going to be P because it weighs more. So P goes down, that means Q goes up. So now let's use forward minus backward is equals to MA. So let's start with P. It's going to be forward is going to be 6 sine theta. Instead of sine theta, I'm writing 0.8 minus tension is equals to mass times acceleration. This is going to be equation 1. Okay. Then for t, it's going to be forward is going to be t minus backward is going to be 4 sine theta. अच्छा इसमें rough surface तो नहीं mention की ना? I don't think so. Rough surface hasn't been mentioned. Okay. So 4 times sine theta is again 0.8 is equals to mass times acceleration. This is going to be equation 2. You'll solve these simultaneously and get A and T. So I'm just giving you the final answers. One A should come out to be 1.6 meters per second square and T should come out to be 3.84 newtons. Okay, you can do this later. Check these answers later. Let's look at part 2. The speed of P when it reaches the ground is 2 meters per second. On reaching the ground, P comes to rest and remains at rest. Q continues to move up the slope but does not reach the pulley. Find the time taken from the instant that the particles are released until Q reaches its greatest height above the ground. Okay. So let's see. Let me just write down the values I need and then I'll clear the rest. Sine theta is 0.8. Cos theta, I doubt I'll need this again, but still. Cos theta is 0.6. Then we have A equals 1.6 and T equals 3.84. Okay. At the speed of P when it reaches the ground is 2 meters per second. Okay. So P started at rest. So it will have a U of 0. So for P, U is 0 and the final speed when it reaches the bottom is 2. And also we know acceleration of the connected particles 1.6. Okay. Now I will ask you to find the final speed before it hits the ground. So what is going to be? अच्छा नहीं वो तो हमें पता है. फिर हमने क्या find करना है? Okay. We know the speed which is 2. The final speed. So that means this gets pulled up till here. And here V is going to be 2 and U was 0. Because that's the time at which P moves from its original spot till to the bottom. So Q moves from its original spot to a point higher on the slope. And U at that instant is 0. V at that instant is 2. अच्छा आपने total time बताना है. Find the time taken from here till the highest point. Okay, so that means for the first part, we're going to find time of this part. We also know the acceleration of the connected particles, it's 1.6. So use these 3 parameters to find T. So we can use V is equals to U plus AT. So 2 is equals to 0 plus 1.6 T. So T comes out to be 1.25. Okay. Now what happens is that when P hits the ground, because of the impact, the string slacks. And as it slacks, it pushes V upwards. Sorry, the point Q upwards. So now the final speed of the particle Q at its maximum height is going to be V is equals to 0. And this becomes U for the second part of the journey, for this part of the journey. So U, the initial speed is 2, the final speed is 0, and we need the time here. So we know what v is 0, we know what u is 2, and you're asked to find the time, total time. Now we need one more parameter, either s or a, to find t. s तो हमें नहीं पता चल सकता। हम्म।
एक्सेलरेशन फ्री फॉल हो जाएगी फिर।
हाँ, क्योंकि स्लैक हो गया ना, नहीं फ्री फॉल नहीं होगी, क्योंकि ग्रेविटेशनल मतलब वर्टिकली अपवर्ड नहीं जा रहे। अगर ऐसा सिस्टम होता ना, यूं करके लगा होता ऑब्जेक्ट, तो फिर स्लैक होता तो हम कहते A-10 है अपवर्ड्स, या वापस आ रहा है तो 10 है। अब ये स्लोप पे है, तो ऐसे नहीं होगा, आपको दोबारा से न्यूटन्स थर्ड लॉ यूज करना है। वो क्या है? फॉरवर्ड फोर्स माइनस बैकवर्ड फोर्स इज इक्वल्स टू ma। अच्छा, फॉरवर्ड फोर्स है टेंशन, टेंशन तो जीरो है क्योंकि स्ट्रिंग हो चुकी है स्लैक। माइनस बैकवर्ड फोर्स है, नीचे की तरफ है mg sin θ, सो इज इक्वल्स टू ma। हम कैंसिल कर देते हैं, ये होगा 10 - 10 इंटू साइन थीटा, क्या है साइन थीटा है 0.8। So acceleration is -8 meters per second. Now you can find t because you have a as well. So u 0 है, v u sorry 2 है, v 0 है, और a -8 है. So we can use v is equals to u plus at. V is equals to 0, u is equals to 2, plus acceleration is -8, and t is what we have to find. So we can do 8t is equals to 2, so t is equals to 1/4. Okay, so that is the time for the yellow part of the journey. आपको total time बताना है Q के original spot से till the highest point of Q. So add both the times. Blue वाली journey का हमें time पता है 1.25, yellow journey का time हमने निकाल लिया है 0.25. So that's going to be 1.5 seconds. ठीक है आयशा, और कोई क्वेश्चन इसमें? 13 भी करा दूं आयशा?
ऐसे हो गया था।
हो गया तो फिर let's start 14. Particle A and B have mass 0.32 kg and 0.48 kgs respectively. The particles, अच्छा मुझे एक सेकंड चाहिए बस। Okay, particle A and B have mass 0.32 and 0.48. इसको जरा plot कर लेते हैं। So B पे there is a downward force of weight which is going to be 4.8 newtons. और A पे भी there is a downward weight force which is 3.2 newtons. Okay, इसी तरह there is going to be a T away from the object, T away from the object. फिर B का क्योंकि contact है surface के साथ, तो there is also an R, normal contact force. A का किसी surface के साथ contact नहीं है, तो A की कोई normal contact force नहीं होगी. The particles are attached to the ends of a light inextensible string which passes over a small smooth pulley fixed at the edge of a smooth horizontal table. The particle B is held on the table at a distance of 1.4 meters from the pulley. A hangs vertically below the pulley at a height of 0.98 meters above the floor. A and B, the string and the pulley are all in the same vertical plane. B is released, A moves downwards. Okay, so they've given you the um, direction of motion. A moves downwards, that means B moves towards the left. Find the acceleration of A and the tension in the string. So again we use forward minus backward is equals to m. अच्छा मुझे ना 2-3 मिनट चाहिए. I'm just coming. आप तब तक इसकी ना इक्वेशन बनाओ. So there's no mention of a rough surface. So smooth horizontal table. So there's no friction. Mu is actually 0, so there's no friction. Okay. Acha, so let's form the equations using Newton's law for both A and B. So for A, it's going to be forward force, which is 3.2, backward force, which is minus T, is equals to M, which is 0.32 times A. Let's call this equation 1. And at B, it's going to be forward force is going to be T minus there's no backward force since there's no friction. Is equals to MA. Mass is 0.48 and A is A. So use either substitution or elimination and find both T and A. So when you do that, you see that A comes out to be 4 meters per second square and T comes out to be 1.92 newtons. Okay. A hits the floor and B continues to move towards the pulley. Find the time taken from the instant that B is released for A to reach the floor. Okay, so first we find the time at which A reaches the floor. Okay. So what do we know about A? For A, U is 0 first, and when it hits the ground, we need the time, and we already know the acceleration of the connected particles, it's 4, and we also know S here, which is 0.98. Okay, so let's use these 3 parameters to find T. So part 2, we can use S is equals to UT plus half AT square. Zero 0.98 is equals to 0 times T plus half 4 T square. We have 0.98 is equals to 2T square. When you solve it, you should get 0.7 seconds. You'll divide with 2 first, and then you'll take square root on both sides. So it's 0.7 seconds. Take 0.7 seconds for A to move from its current stationary position to the floor. Okay, acha ji. Next is find the time taken from the instant that B is released for B to reach the pulley. Okay, so पहले क्या होगा कि A ने इतना डिस्टेंस कवर किया है 0.7 सेकेंड्स में, तो इतना ही डिस्टेंस B कवर करेगा 0.7 सेकेंड्स में. तो लेट्स से B यहाँ आ गया, तो we know this distance, this would be the same distance 0.98, and then we can find the remaining distance from 1.4 minus 0.98. So that's going to be 0.6. 1.4 minus 0.98. No, it's actually 0.46. So we know S for this part of the journey. Okay, this is the second part of the journey. And that's the first part of the journey. It's the same as this journey. Okay. So we know the S for this part of the journey. Okay. Then what else? A find करना है for this part of the journey. But in this part, the string slacks because there's an impact at the end of the blue journey. So then this string will slack and make the B particle move towards the pulley. So we need the new acceleration. That is going to be T, which is 0. Now forward force T, which is 0, minus backward force, that is also 0. But उससे तो acceleration 0 हो जाएगी. Forward will be 0 because minus 0 is equals to mass times A. That means acceleration is 0. So that means that that's a constant speed. If acceleration is 0, that means the speed is constant. Okay. So forward force minus backward force is equals to M, which is 0.48 A. So it's actually A is equals to 0. That means constant speed. So now you don't have to use the equations of motion. You have just one equation of motion, which is speed is equals to distance over time. V is equals to S over T, or S is equals to VT. Okay. So now time would be distance over speed. Distance हमें पता है 0.4, but speed नहीं पता. 0.46 है distance, sorry. Okay. अब speed कैसे निकालेंगे? The speed at this instant is the speed at this instant, right before it hits the ground. So we have lots of parameters for A. We can use that to find V. I'm going to use V is equals to U plus AT. ये A के लिए use हो रहा है. So V is equals to U0 है plus A4 है और time हमने निकाला था. क्या time आया था? 0.7 seconds. So this is going to be 2.8 meters per second. Okay, so that's going to be the speed for the yellow part of the journey and it stays constant. So फिर हम time कर लेंगे. Time is equals to 0.46 over 2.8, which gives 0.15 seconds. अच्छा ये गलती हुई है. ये डिस्टेंस जो था ना वो 0.42 था, नॉट 0.46. This was 0.42. When you subtract 1.4 and 0.98 तो वो 0.42 आता है. तो यहाँ पे भी 0.42 है और यहाँ पे भी 0.42. So 0.42 divided by 2.8 से आ जाता है 0.15. अब टोटल टाइम चाहिए फॉर बोथ पार्ट्स ऑफ द जर्नी ऑफ बी. सो फर्स्ट का टाइम था 0.7 सेकेंड्स, नेक्स्ट का आ गया 1.5. तो ये हो जाएगा 2.2. एक सेकेंड, मुझे लगता है 1.5 नहीं है. हाउ कैन इट बी 1.5? 0.42 डिवाइड बाय 2.8, सॉरी 0.15. So 0.15, and when you add 0.7 and 0.15, we get 0.85. And that is the correct answer. Let's do question 15 now. अच्छा 15 पे ना आई एम गोइंग टू अप्लाई लेमीज थ्योरम. आई डोंट थिंक मैंने पहले आप लोगों को अप्लाई करके दिखाया हुआ. आई थिंक नोट्स में लिखवाया हुआ है बट मैंने कभी किसी क्वेश्चन में अप्लाई नहीं किया. This theorem says, let me recap that. Lemmy's theorem. It says that if you have three forces emerging from the same point, let's say F1, F2, and F3, and then you have angles opposite to the forces. Let's say this is theta 1, let's call this theta 2, and let's call this theta 3. So then F1 over sine of its opposite angle is equals to F2 over sine of its opposite angle is equals to F3 over sine of its opposite angle. Only works for three forces. अगर ये four forces हों originating from a point तो फिर Lemmy's theorem does not work. लेमी थ्योरम से हमारी वर्किंग काफी इजी हो जाती है. हमें बाकी फोर्सेस को रिजॉल्व वगैरह नहीं करना पड़ता हॉरिजॉन्टल और वर्टिकल कंपोनेंट. चलो now we will be applying this in this question because I need you to get used to this Lemmy's theorem as well. Okay, each of the three light strings has a particle attached to one of its end. Okay, अब ये three strings है. The other end of the string are tied together to point A. अच्छा, अब ये एक string है. इधर से शुरू हो रहा है, यहाँ पे ए पे खत्म हो रहा है. फिर ये एक स्ट्रिंग है, इधर से शुरू हो रहा है और इधर खत्म हो रहा है. और फिर एक थर्ड स्ट्रिंग है जो यहाँ से शुरू हो रहा है, यहाँ पे खत्म हो रहा है. अब since these are three different strings, इन पे three different tension की. So now you're going to use T1, T2 and T3. So यहाँ पे T1 है upwards और W1 है downwards. यहाँ पे let's call it T2 upwards और 5 न्यूटन डाउनवर्ड्स. और यहाँ पे होगा लास्टली T3 upwards और W2 downwards. Okay. अच्छा जी, let me in fact call this T2 and W2 और इसको 3 कहते हैं. मिडल वाले को 3 कह देते हैं. Okay. अच्छा तो when the system is at rest तो फिर T is going to be W1, forward force is equals to backward force. T3 जो है वो 5 के इक्वल है और T2 जो है वो W2 के इक्वल है. ठीक है. अच्छा, फाइंड द वैल्यू. एंगल्स गिवन है हमें 40 और 60 और कहा हुआ है फाइंड द वैल्यू ऑफ W1 एंड W2. लेमीज थ्योरम यूज करेंगे. अच्छा जी, अब जो ब्लैक स्ट्रिंग है उसमें टेंशन थ्रू आउट सेम रहेगी. सो इफ द टेंशन इज इक्वल्स टू W1, so it's going to stay the same throughout the string. So अगर मैं इस रेफरेंस से देख रही हूँ इस पॉइंट के, so then I can point T outwards, T1. Here I can point T2 outwards और फिर हम डाउनवर्ड करेंगे T2. ठीक है, क्योंकि अब हम इस मीटिंग पॉइंट के रेफरेंस से देख रहे हैं. तो द tension always points away from the point or the mass given or the particle given. So अब जो सेंटर के रिस्पेक्ट से टेंशन होंगी वो सारी आउटवर्ड्स होंगी बट टेंशन की वैल्यू सेम रहेगी. So I'm going to apply Lemmy's theorem here. बल्कि I know all the opposite angles as well. ये वाला एंगल क्या हो जाएगा, 180 माइनस 40 140, और ये वाला एंगल हो जाएगा 180 माइनस 60 120। ठीक है, सो आई एम गोइंग टू यूज लेमी थ्योरम, तो आई एम राइटिंग T1 ओवर T1 के ऑपोजिट ये पूरा एंगल है, ये एंगल है T1 के ऑपोजिट, it is 120. So T1 over sine 120 is equals to T2, उसके opposite है 140, and is equals to T3 over 5 sine, in fact उसके opposite है 600 sine 100. Okay, अब T1 की जगह मैं लिख रही हूँ W1, because T1 and W1 are they're equal, because यहाँ से पता चल रहा है. Okay, T2 की जगह आई एम राइटिंग W2, और T3 की जगह आई एम राइटिंग 5. So now you need use the first and the last fraction to get W1, and then the second and the last fraction to get W2. So W1 over sine 120 is equals to 5 by sine. And then to find W2, we can use the second fraction and the last fraction. W2 over sine 140 equals 5 over sine 100. You'll cross multiply and you get W1 and W2. Okay, when you solve this, you'll get 4.4 for W1 and 3.26 newtons for W2. Okay. So that's all from mechanics for today.